Hello everyone again. I hope you're enjoying the weekend. As always, this is my, I think, 11th live stream. Today my goal is to continue what we did in the past, so just expand on the Rust query modules infrastructure. Again, I'll try to be quick. Basically, the plan for today is to do a vertices iterator, but that we had that before. It was a bit wrong, but I think this time I'll manage to implement that correctly, and also do a little bit of cleanup with strings and similar. That's more or less it. I think I'll be done under an hour, but we'll see about that, since I didn't prepare everything, so we'll see what will go wrong. And yeah, if you would like to get notifications for content like this, please subscribe in the channel, and also like and share. So I think that's about it for the intro. Let's jump into the code. So let's go back here. We stopped last time more or less here, basically just iterating through the vertices, and then printing the number of labels. This time I'll just try to improve that code a bit and make it, let's say, more rusty, and yeah, do the cleanup in general. So I did a little bit of preparation today. So last time we had something like this. We created the iterator, and then we were calling next in the loop. The problem with that is that Memgraph C API is a little bit specific, so it has iterator get and iterator next, but iterator get has to be called initially to get the first vertex, and then iterator next has to be called for every other time to get the vertex. And then the problem was that in our code we skipped the first vertex. And what I did today, I've implemented. Where is that code now? Sorry. Here. So I've implemented the iterator class. Iterator trait, sorry, for the MGP vertices iterator. Essentially, a programmer has to implement only the next method, and that will return the item from the set throughout which iterator is going. And basically what I did here, I've just call vertices iterator in the first instance. So whenever if I had to add, I don't know how to do that better. I had to add the isFirst flag to the iterator. Maybe that can be done slightly better, but let's leave it like this for now. And then on the first iteration, we just return iterator the result from iterator get, and on every other iteration we use iterator next until it returns null. when it returns null, then we also return none. So yeah, the next method here is returning an option. An option can have nothing inside or some value. And if any of these two method functions return null, then we return none. Otherwise, we return the data. That essentially means we can delete these two from the code. Yeah. So we can delete these two methods from the code because we won't need that anymore, since that's all abstracted now. That's fine. And then okay, that's fine. Let's change that code. Sorry. I'll just, for the sake of demo, I'll return this here a bit because I want to showcase this. So the module is now compiled, and I'll run container with the module. I'll try to run this just to showcase that it's working. And yeah, one more thing I forgot to mention is that I've created another procedure. Where is that now? That this here. So it just implements. It just uses the iterator and iterates through with the for loop through the vertices, and it just prints the labels count. So yeah, I've started Memgraph here. I've created these nodes. That's fine. And now I'll run the procedure. It returns nothing, but in the sorry, I'm a bit messy today. In the terminal, 1 to 3 is written, and that's correct because there are 3 vertices, and each have one, and the other vertex has 2 labels, etc. If we rerun this, we should get the same thing one more time. So yeah, that's fine. Okay, now let's. This is just a quick and dirty demo. Let's delete this redundant stuff now. Yeah, this here is not needed anymore. And I'll just test procedure. Okay, this is not needed anymore. This is all useless. Result. That's from here. I think we need this part here. So to return these things to the caller. Okay. I still didn't fix the formatting, so bear with me on this. So result, we make the result, MGP vertex is here, and everything else should be fine. Print is not needed anymore. FMT. That's okay. So, okay. We don't need the old testing procedure, which is fine. And this code is now slightly better. It's slightly shorter because we don't have to call these 2 methods anymore. Let's try to compile this. Yeah, it's okay. And if we go here and we reload, call mg procedures load all. What did happen with Memgraph? Okay, we reloaded, and if we call this, boom, we now have labels count listed here. And yeah, by the way, on just a side note, on some of the initial streams when I did the code in C, I had issues with reloading procedures. In the meantime, we figured out the problem. The problem wasn't in the reloading procedures, but rather in query plan cache. And because we changed the procedure and procedure signature, but in the plan cache, still the same query with the old procedure was cached, and then that break, then the procedures didn't reload, and we fixed that, and that will be published soon in our next release. So these reload and load procedures call will work every time correct. Yeah, that's just a side note. Let's continue here. So yeah, one more thing that bothers me is that the iterator, where is that code now? The iterator has that flag is first bool. The problem with that is it's some kind of an internal structure that shouldn't be exposed to the caller. But here, since we have that as a part of the struct, I have to initialize that value. And I have to say that explicitly, which is bad because people can make a mistake here. So what we should do, we should create a default value for this first, and then I research how to do that. And there is Rust default, so that's a trait that gives an option to write to specify default values of a struct. There is also a derived default, I forgot how is that called. That's a default implementation of default, but the problem with that is that we have pointers and the default implementation doesn't work. So we have to implement our own implementation for this struct here, and I'll do that right now. Implement MGP vertices iterator. Implement default for, even though that can go up. Implement default, and then we have fn default. Sorry, how is that? Default self. So default, it returns self. So self in this context means MGP vertices iterator with upper with camel case self, and we return, I think, self, and then put the I think this should work. Is first, so is first true. We want that to be true. Yeah. What's the problem here? We have a const pointer. How to fix that? Rust. Where is null? What is this? Nullity. Mutable null mute. Okay. Null mute. This should work. Yeah. Okay, great. But why it doesn't say here? I haven't seen this in the documentation. As mute as null. That's struct. Yeah, okay, anyway, so yeah, this should work. So when we need a mutable null pointer, we can call stdptr null mute, and that will return what we need. So great, that will work. And then we use that somewhere below here. And to do that, as we remember from the previous from the tutorial, I think this should work. So this should that will initialize all other fields in the comma doesn't work. Okay. Yeah, okay, great. That's fine now. And since we also, here is a bit MGP, that's already contained in the vertices iterator method. So by doing that, we already have that abstracted, so in that function, so we'll never have to call this default really. Okay, makes sense. So that's here. Great. So let me see what we did. So we did the iterator, the default implementation, and then we removed these two methods. And then also we removed this chunk of code, which is great. Okay. So I'll then remove this and this and this. So that's more or less it about the iterator. And what I also wanted to do is to figure out this to do. So this is now a slightly different topic. We initialized all these C strings, and that has a couple of problems because for each call, almost for each method we are doing, we are calling, not for each method, so for each procedure, we'll create we'll make multiple calls to these functions. And in the case of an error, we have to construct an error string. And that's expensive to do that every single time on the fly. And instead of doing these, let's say, on the fly, the dynamically allocated strings, we should use static strings and pass that as an error, because we waste a lot of resources otherwise. And my goal, and then I googled what to do on that end, and I found this crate. It seems something pretty good to have. So it says a macro to produce C compatible string data literals, which is exactly what we need, I think. In Rust code, we need null terminated strings, and we need something like that, and then we'll use that for the errors. So let me just do. So I'll just push this code, because yeah, the part of the good coding practices is also to commit atomic or isolated piece of code. So in this commit, we'll just push iterator related stuff. So I'll just git commit. So this is, I have an alias for commit, which is CT, and -m, which is message, at iterator gp at below. Yeah, this is nice, according to the Rust syntax. Okay, git push, we push that just to add this. Okay, great. And now we have a clean start for the rest of the code. So let's go back to this. So this is a crate, and I think we have to install that. So let's go back. So version is 1.2. If we go in the repository, this is quite old crate. Last update was 3 years ago. But yeah, I don't see issues with that, since it's very simple stuff. So basically that's like one file doing these macro stuff. Yeah, let's just check the implementation, what is actually going on. So we define a macro from pointer. We add I hope this is done under the hood efficiently. We might in the future profile that and see what is going on under the hood in the code. Yeah, maybe I can even do that. So maybe I can even do that now, because this very simple code here, and this we don't need. let's see what we'll get out of this Rust. So this is for people who don't know, this is a Codebolt compiler explorer, which is very suitable for playing around with the code and getting the compiler output, so that you understand what is going on. So you can better understand what is going on. But yeah, let me just the main and then something. Maybe do they have why is the compilation? Are we missing something? Yeah, probably some header or something. Can I get the yeah, sorry. Mismatched types because the folder turned expected. Okay, let's put it here. So this dot here is completely optimized now. So we just got nothing. Basically everything is optimized from the final output, which is not great. How to do something useful here? So let's do print. What about this? Print. Now the same problem. What if I do this? Where is my output disappeared? Sorry, I've never used this for the Rust code, so I'm not sure what is going on. Let's do some basic stuff. So this all gets optimized somehow. Yeah, I don't understand why is that completely optimized. Add new. Not sure why I don't get any output here. So yeah, I'll skip this for now. Skip this for now. Go back to the code. Anyway. Let's go back here. So I'll try to do the code first, and then we'll go back if we'll have time to figure out what is the output here. But in any case, so maybe we can do that from the getting. Maybe we can do that from the cargo rust C emit ASM. Interesting. Let's do that. We'll see what we get here. Let's try to do this, but in our main. Yeah. Okay. What? How is this possible? Sorry, this is a bit messy now, but we'll get to something meaningful, I hope. And now we do this. Rust-C can only be passed to one target. Consider filtering the package by passing. What did I get? Debug. Debug depths. Mage, and then A0. Okay. This seems a bit better. Boom. Great. We have that label inside our code for optimized assembly. We have to add release. Great. So we do here minus minus release. So that will run an optimized version of. So we never actually built Mage in the release mode yet, but this will build Mage in the release mode, and hopefully, okay, now we have that binary in the release mode. Let's do I forgot how to minus b minus a, so minus b2 minus a2. So that will print our test character here. So unnamed label 2, which is I think that's fine, because this is now a label in the assembly, which means it's not dynamically allocated, and I think that's the case, so it's pretty good. And yeah, but why is that output so huge? Maybe there is another. I'm sorry. Release depths Mage. Yeah, this now looks much better. Let's do slightly. Okay, now we optimize, but now we build that again, and we still have that file. Great. Minus b10 minus a10. So okay, we have that unnamed object here, which is here. And yeah, but yeah, I think we proved that that's not dynamically allocated, which is great, because that's somewhere in the assembly code. Maybe we didn't, because it's used somewhere else. Let's search for that label. L underscore unnamed 2. So let's just Google what does this instruction do. I mean that's some kind of a comparison or something. Q unnamed. load effective address is often used as a trick to do certain computations, but that's not the primary purpose. Yeah, I think that instruction loads the address of that label into the register, and then it calls the method this is formatting, so we are loading that address, and then we call the pointer stuff. And where is that located? From pointer concat. We also need a concat method. Yeah, I'm not sure. I'm pretty sure it gets it doesn't get created dynamically, but I'm not sure how many times the concat method is the concat, but that's also macro. How is that implemented? Static string, which represents all of the letters left to right. Great. So we also have a static string here, which is concatenated, and that's great because we need just that. Okay, I'm pretty confident we're good here. Yeah, hopefully I've managed also to showcase how to get the assembly output out of the code you have. Yeah, we can spend here a bunch of time, but let's leave it like that for now. I'll revert this here to what we had before, and let's quit all this for now. And yeah, I'll use that as a next iteration in any case. So I'll just install that. So this has to be installed as a dependency. I had that before. I'll just save this. Yes. So we added here the dependency cstr macro, the last version available, and we'll just, and yeah, it says here on the documentation, this is how we use these things. So I'll go into lib, and I'll also put this here. Okay, that's fine now, and yeah, let's go back here. So we use this by calling cstr and then something. So we'll just go back whenever we use C string. Okay. Okay, here is the first instance. So let how to, so more or less we have to delete this and replace C string new. So I'll try to do that. New with C str. Yes. Okay. So we have one usage of that, and then if we need, let's try to compile this. Cargo build not found into row. I think we need sptr. Yep. Okay. And of course, I think we can just, for to be 100% sure about these things, we can also like use that globally, and that will be fine. Yeah, I'll definitely leave it as is for now. Okay, where else? Sorry. Not here. Here, yes. Here, yes. Not here. Yes. No. Yes. No. Yes. We'll see about this, but okay. That might not work. Okay. Since we also need a string here, I think mg procedure. What mg prots add? We need const char. Yeah, that's gonna work. So we just replace not this, name into bytes as ptr. I think this should fly. We'll see. Let's leave this as is for now. I'm just doing the refactoring now. As ptr. Hopefully I'll do that quickly. This is very similar type of problem. insert result record. Here we have actual problem that we have the string that is passed. Yeah. Here we actually have to. But we should replace all of that with another type. Okay. Insert result record. So we are turning that into this. Let's completely remove this. Now we're gonna get a bunch of errors, but anyway. And CSTR is a reference that we have. We have to replace that with CSTR. So add result type is our method, and we add it here. What's the name? Okay. This is a huge mess now, but we're gonna fix that. Okay. Let's go one by one. So only literals. That might be a problem. I can use only literals to pass them around. So and I have to completely remove that, and which is that method. So 818.181. Sorry. So insert mgp CSTR. We can remove this completely, and mgp name. I think that's gonna fly. Sorry. And we can here do the same. Name not inserted message. Yes. And great. Yeah, I think we fixed that. Yeah, so just to explain, so here we had two problems because once we have we had to create a result record name and also the error in case something fails. So with the error we have the same approach as before. We have the literal embedded here, but with the record name we passed here CSTR, and let's just check str rust. So CSTR rust, what's that? Borrowed C string, which is fine. I'm completely fine with it. We just need C string, and which is going around through these methods. Yeah, okay. And then insert result record, and we have here the actual literal, which is, I think, very nice. Okay, and then we just do this for the rest. Test procedure, and then add, yeah, and then instead of name we do ref C string, and then we just do name as ptr. We don't need this. Uh-oh. Cannot find. Ah. All right. Yeah, now we have a problem. Found for reference. So 2, 4, 5. 2, 4, 5. This is a problem. We can't use this. Mm-hmm. That's not gonna fly because of the we need to create that object. And how is that library implemented? So if we go back, we create C string from that pointer, and then we cast it to the char C char. So Now it doesn't complain, which is kinda okay. Okay, what about the rest? So that's here. Let's try to do the same here. All right, this seems something promising. Oh. Okay, we have one more of these, so that's into by. But that's name.sptr. Okay, nice. And we don't have C strings anymore, which is great. So we delete this. But how did I get that working so quickly? Okay, so we have the C strings here. We have the C string here, which is exactly what we need. We have this here, we have this here. We have correct thing here. We have okay thing here. We have this here. Okay, so let's compile one more time. It's working. We'll just labels count test procedure. So we should be able to reload stuff. It doesn't complain. Great. Sorry for hooray! It works. So we simplify. I really like what we did here, because we simplify the code, and also I think make it more optimal. We'll test that in the future for sure. But yeah, that should be it. Great. Just quickly, so we added that cargo package. We added that as a dependency. Fine. We removed C-string, which is great. We removed the to-do. We removed this here. Let's just do one more thing. No. Okay. So we have we removed the C string here. We remove this one. We remove this one. We remove this one. We replaced C string with C string. We completely ditched this part. And that's it. Great. I think that's exactly what we wanted to do. Is there anything else left? To do. So we have a couple of more to-dos. Test model. That's not in the mage, so let's rust ag to do. So yeah, in the Rust part we only have vertex data, but I'll add more stuff. So yeah, that's okay. Migrate to, how is that called? CSTR macro. And that's about it. So we managed to do all both of these things, and I'll stop here for today. No questions in the chat. So yeah. If you have any questions, please put them in the chat or put them in the video after I finish. It's not a problem. I'll try to answer them as soon as possible. Let's go back here. I think we are good here. Yeah. Let's step back. So in general, this goes slower, much slower than expected. But yeah, we are making progress slowly, but making progress, which is always the most important thing. Next time I'll continue. I'll probably add more about on the vertex side and getting data out, because there is a lot of work still there, because we have to add a bunch of methods and functionalities so that the Rust query modules are super easy to use. And I'll continue with that. Probably I'll try to make the whole Vertex API covered so that we can do anything with vertexes inside Memgraph. But yeah, that's an optimistic plan. We'll see about that. And yeah, that's about it for today. Have a good rest of the weekend, and yeah, see you next Saturday. Bye bye.